So in this latest video looking at area and perimeter, we're focusing on compound shapes. Now a compound shape is a shape built by joining common shapes together. Now often you will be asked to find the perimeter and the area of these built up shapes. So as you can see in terms of the examples here, our first shape is made up by a triangle and what looks to be a square, although you can never take it for granted because it could potentially be a rectangle. Our second shape is built up by, again, two rectangles. Now again, we could either split this shape up so they're the two rectangles, or we could split it up so that we've got our two rectangles here. Now what you don't want to do is you want to limit the number of shapes that you are seeing. So I certainly would not split this shape up into, let's say, 3 shapes. You want to try and keep the number of shapes as small as possible, because obviously the more shapes you have, the longer it's going to take for you to work with, and the more complicated you'll make the question. Now in terms of our third shape here, we've got a semicircle, and we've got what looks to be a rectangle. And in our final shape here, we've got a triangle, and again what appears to be a rectangle. Now when I say what appears to be a rectangle, it's only because we don't know the measurements, and often these shapes that you tend to find either in textbooks or for homework sheets or exams are never going to be drawn to scale, because the last thing they want you to do is to use a ruler and start measuring or counting squares inside the shape. Now because of their uniqueness, there is no set formula to easily and quickly work out the perimeter and the area of these shapes, so they must be done separately, slowly, and in parts. Now just a quick refresh of the perimeter. Now the perimeter is the shortest distance around a shape and can be calculated by adding all the lengths of the shapes together, whether they're straight or curved. And the units that we use for perimeter are going to be just simple length units, so either millimeters, centimeters, meters, kilometers, etc. Now the area is, the definition of the area is the number of squares that fit inside a shape. Now those sizes of the squares can vary depending on the units that you're looking at, so whether they're millimeter squares or centimeter squares or meter squared or kilometer squared even, so that's why it kind of fluctuates. Now calculating the area varies based on its shape, and answers of the area are going to be measured in square length units, so either millimeter squared, centimeter squared, meter squared, kilometer squared, etc. Now it's really important that you know now I know with maths, and one of the frustrating things with maths is that you're having to learn so many different formulas, but there is also smart ways of recognizing the amount of formulas that you've got to use, and one way is kind of developing your own shortcuts and understanding how that area is actually calculated. Now in terms of a compound shape, they can be an amalgamation of so many different shapes. Now the common shapes that you're probably more aware of are squares, rectangles, parallelograms, triangles, rhombuses, kites, then you've got circles, and then you've also got trapeziums. Now I'm going to include a note sheet in the description below which has got all the formulas, but one thing you might want to notice that might help you revise the formulas for all of these shapes is recognizing that some shapes are grouped and have the same formula. So for example, square, rectangle, parallelogram I should say, are all calculated by doing the base times the height. So as long as you remember those three and you know that they're that formula, then that will be one way of working out. And again, a square is pretty much like a rectangle, and a parallelogram is just like a wonky rectangle. So it's just a case of working from there. Now a triangle, rhombus, and a kite. Now you can see from all of those shapes, they're kind of made by joining triangles together. So when you see a rhombus, if you see two triangles, when you see a kite, you can see two sort of isosceles triangles joined together. Then you think, right, triangles, base times height divided by 2, or half base times height divided by half base times height, whichever formula you want to use. Now when it comes to a circle, again with these compound shapes, you could have, it's unlikely you'll have a full circle, which the formula is pi times r squared. More often than not, you'll either have a semicircle or you would have a quarter circle, in which all you then need to do with the formula of pi r squared is either divide it by 2 if you're looking at a semicircle, or divide it by 4 to work out a quarter circle. Now obviously when it comes to the perimeter, this is where you're looking at the circumference, and this is probably one thing that is going to be missing. So the circumference of a circle is going to be pi times the diameter, or what you could use is 2 times pi times the radius. Now it doesn't really matter which one you go for because they're both the same, because basically the diameter is twice the size of the radius. So if you know what the radius is, you times it by 2 and that's the diameter, or if you know the diameter and want to work out the radius, you just divide that by 2. So in terms of this length here, let me just use a different color. So on the circle, so what this, if I just go around this circumference of this circle pretty much quite poorly, it's not too bad actually. So the perimeter of this green length is going to be pi times the diameter. And again, obviously, if we know the radius, then it's going to be 4, 2 times pi times r. Now, if I was to work out the curved section of a semicircle, then this would be pi times d divided by 2 because it's half a circle, or it would be 2 times pi times r divided by 2, which the 2's would cancel, so it'd just be pi times r, but we won't go into that just yet. Now, the key thing to remember when you're working out the perimeter of a semicircle is don't forget this straight side. So it's always important that you don't forget, the straight edge. And that straight edge is either going to be d, the diameter, or 2 lots of r, which would be 2 lots of the radius. Now, the same thing applies to when you're looking at a quarter circle for the perimeter. So this blue length here of the curved area is going to be pi times d, which is the circumference of a circle, but we're not looking at a whole circle, we're looking at a quarter circle, so that's why I'm going to divide that by 4. And again, you could work with the formula of 2 pi r, but again, you're going to be dividing that by 4, which gives you pi r divided by 2. But again, it starts to get complicated. The other key thing to remember is that when you're working out the perimeter of a quartic circle, is don't forget again the 2 sides here. So that's going to be r, and that's going to be r as well. So when you're working out the perimeter of a circle, just bear in mind that there may be additional parts rather than just focusing on that curved area. And then what then leads on to the perimeter or the area of a trapezium. Now, to work out the area of a trapezium, we're just looking at the 2 parallel lengths and the height. You don't need to know the lengths of the diagonal sides. You only need to know that if you're working out the perimeter. So it's just something to bear in mind when you're working that out. And that's another key note that I probably should focus on, is when you're working out the area, you don't necessarily need to know all the lengths, whereas you do need to know all the lengths of all the sides when you're working out the perimeter. Now, again, there is a copy of this note sheet in the description below, which if you're not comfortable with working with area of these shapes or forgetting the formulas, then I strongly recommend that you either copy or download that note sheet. Now, when it comes to compound shapes, and let's just get this fully on the screen. So when asked to find the perimeter, it is important to find the length of all the sides and the edges. Some may be missing, but it will always be possible to find the missing lengths by comparing it to opposite sides. Now, for diagonals of triangles, you may need to use Pythagoras theorem, which if you've got absolutely no idea what I'm talking about Pythagoras, then it may be a topic that you'll be doing in the future. But again, that's going to be classed as rather a higher level question if you are asked to incorporate Pythagoras theorem when working out the perimeter of a compound shape, but it's not impossible. Now, for the area, simply split the shape up into the common shapes, just like we did at the start of this video. So either into squares, rectangles, triangles, trapeziums, semicircles, etc. But like I said, you want to try and keep the number of shapes to a bare minimum. So if it's possible to split a shape up into 2 common shapes, then go for 2. Try not to split it up into so many, because again, it's just going to prolong your ability to answer this question correctly. Then, to ensure you have the correct lengths given, you don't need all of them as mentioned. To find the area of each individual shape, find these areas before adding them all together to get the total area of the compound shape. Now again, the key thing there is just make sure that the length units are all the same before any calculations, which again is something to bear in mind and may involve where you've got a big mock question where you might have to convert some of the lengths. So whenever you're working with perimeter or area, always make sure that you're working with the same unit. So if one length is in meters and the other is in centimeters, make sure you convert them so they are both the same. So either both in centimeters or both in meters. And again, if there's no indication in the question what unit they want you to use, then you can pretty much use whichever you want. So have that freedom and be comfortable. But that should be always your first initial check whenever you're asked to work out perimeter or area, is always make sure that the length units are the same. Because again, otherwise you're going to have to start all over again and all sort of tinker with the final answer. So let's have a look at some example questions. So in this question, we're asked to find the perimeter and the area of this shape. So first things first, I'm going to establish how is this shape created? Well, this shape is created by, I would say, 2 rectangles. Next thing I then got to look at is, do I know the lengths of all the sides? Well, in this case, no. So starting off with the perimeter. Now I know what this side here is. I'm going to highlight in orange. I know what this side here is, which is 13. I know what this length here is, which is 4, and I know what this length here, which is 8. Now, I'll be honest, there are so many occasions where students have got their ruler out and started measuring. These diagrams are never going to be drawn to scale, so try and stay away from your ruler and try and use kind of common sense to work this out. Now the two lengths I don't know, which I need to know for the perimeter at least, is going to be this length here, and if I get a different colour, which is going to be this length here. Now if I move that green length, now I know that the height of this shape, which on the left hand side is 10, I won't say height, but the left hand side is 10. If I moved that green side over to here, and I moved this orange line here down, you can see there that what I've made is I've made a rectangle. Now all of this length here, let's get a different colour, so all of this length here must add up to 10. Okay, now if this length here is 4, then what plus 4 gives you 10? Well, that must equal 6. Now it doesn't look like 6, which is why these diagrams are never drawn to scale. So yes, you might think, that doesn't quite look right, but have a bit of faith in terms of your sort of knowledge. So this length here, the green line, is going to be 6 centimeters. Now likewise, this sort of base of this rectangle, so all of this distance is 13. How do I know that? Because it's the top length here. Now if up to here is 8, so what plus 8 is going to give me 13? Well, that's going to give me 5. So this length here is going to be 5 centimeters. And so now what I've got is I've got all the lengths of that particular shape. Now by knowing all the lengths, let me just rub out all of this unnecessary stuff. I wouldn't say unnecessary because I actually needed it to work out all of those. And so now I've got all the lengths, I can now work with answering the actual question. Now it's really important that you don't need to show those calculations, you can write it in your diagram and that'll be more than enough to get the marks. So already I've got a few marks without even working out the perimeter or the area by writing down what those missing sides are going to be. So to work out the perimeter, all I need to do is pick a starting point, which I'm going to start here, and I'm going in a clockwise direction, going along all the edges, and I'm just going to go along adding them all up until I get back to my original place. So here the perimeter is going to equal 13 plus 4 plus 8 plus 6 plus 5 plus 10. It's always worth just double checking how many sides the shape got. Well, it's got 6 sides, and again, have you got 6 lengths? 1, 2, 3, 4, 5, 6. Yeah, absolutely spot on. So I can then go on to add all these up. So again, I've got 13 plus 4, which is 17, plus 8, which is 25, plus 6, which is 31, then 36, so equals 46 centimeters. And there is my final answer. Now when it comes to the area, now as we talked about, there is no formula to work out the area of a compound shape because it is just two shapes or a couple of shapes just merged together. So what I'm going to do is I'm going to split this shape up into two parts. Now it doesn't really matter how you split this up, but I'm definitely not going to split it up so it makes it more complicated. So you've got a choice. I would say the most simplest way to split the shape up is like this, or I could split it up like this. Now it doesn't really matter how you split it up. You might have different working to someone who split it up differently, but you should still end up with the same answer. Now just for argument's sake, I'm going to go for the first one. So here I've got two rectangles. Let me just get rid of that. So here I've got two shapes. I'm going to call this shape A and I'm going to call this shape B. Now the total area is the area of A plus the area of B. Now the area of A is basically this rectangle here, and to work out the area of a rectangle, it's just the base times the height or the length times the width, whichever floats your boat. So I've got 8 times 4, which is 32. So the area of A is going to be 32. Now the next thing I've then got to do is now work out the area of B. So using the measurements of B, now you just got to make sure you're using the right measurements. So I'm looking at the height by the base. So the area of B is going to be 5 times 10. So that's going to give me 50. And then so all I've got to do is add 32 to 50, giving me a final answer of 82. And then the units are going to be centimetre squared. And there is my final answer. So moving on to this next question. So again, I'm working out the area and the perimeter of this particular shape, and I can see straight away that I'm certainly missing a few lengths. So I'm missing what this length here is, I'm missing what this length here is, and I'm also missing what length this shape here is. Now again, using my common sense, let's have a look if I can actually work that out. Well, I can see that generally speaking that these two lengths here are going to be the same. It looks like a rectangle, so this here is going to be 15 centimeters. And likewise, I would say that this length here is going to be 10 centimeters, because obviously the opposite side is also 10. So the only length I've really got to find is what this length here is. Now again, looking at the base, the total, so I know all of this has got to add up to 25. Now this here is 2 and this here is 8. So adding those two lengths up, I get 10. So what plus 10 gives you 25? Well, that's going to be 15. So the length of this is going to be 15 centimeters. And again, it's very deceiving because it doesn't look like it's 15, but that's the whole point. It's to get you to think about these questions to make sure that you are getting these questions correct. So again, let's just get rid of all these calculations just to make it a little bit easier, so I'm not doubling up on the questions that I'm asked to find. And let's go with this because we know that's 25. So working out the perimeter of this shape, again, I'm going to pick a starting point. Doesn't really matter where the starting point is. So I'm going to pick this point here. And all I'm going to do is going to go around in a clockwise direction. Again, doesn't really matter where you're going clockwise. Just make sure you're including all the lengths. So here I've got 15 plus 10 plus 8 plus 15 plus 25 plus 15 plus 2 plus 10. And again, so adding all of those up. So I've got 15 plus 10 plus 8 plus 15 plus 25 plus 15 plus 2 plus 10, and I get a final answer of 100, and it's going to be in centimeters, and there is my final answer. Now when it comes to the area, again, what I'm going to do is I'm going to split the shape up into two sections. So probably easily it's going to be these two shapes, and again I'm going to label them A and B. Now for shape A, looking at the dimensions, I need to know the length and the width. So area A, so let me just write down this, so the total area is going to be area A plus area B. So area A is 10 times 15, which is 150. So that's going to be 150 there. And then to work out the area of B, well again, I'm going to be using 25 and I'm going to be using 15. So that's going to be 15 times 25. And 15 times 25 gives me an answer of 375. So then adding these up, I get a final answer of 525 centimeters squared, and there is my final answer. Now, if you were to get any decimal answers, then obviously you can round it up. Just make sure you're reading the question carefully to make sure if they're wanting it in particular decimal places, and then obviously if not, then you kind of choose. If you're nervous about rounding numbers up, then just write down whatever your calculator's showing if it's a calculator question. But generally speaking, these questions could easily appear on both the calculator and the non-calculator paper. It just depends on what numbers you're working with. So moving on to our next question. So looking at this, so here we've got a bit more of another compound shape. I can see straight away that this is a triangle and a rectangle. So looking at the shape, are there any missing sides? Well, looking at it, no, there actually isn't. So here I can go straight into working out the perimeter. So working out the perimeter, I'm going to start at this peak of this shape. So I'm going to just add along as I'm going along. So I've got 5 plus 6 plus 2 plus 9 plus 6. Again, before I continue, just make sure that all the units are the same. So none of those are in centimeters, they're all in millimeters, so that's all good. So adding these up, I've got 5 plus 6, which is 11, 13, 22, 28. So it's going to be 28, and it's in millimeters. There's my final answer. Now, moving on to the area. So again, I'm going to call this shape shape A and this shape B. So the area is basically the area of A plus the area B. Now I notice straight away that area A is a triangle. Now to work out the area of a triangle, it's the base times the height divided by 2. Now do I know each of those lengths? Well, in theory, not at the moment. So I need to work out what this length here is. Now all of this is 6, but this length here is 2. So 6 take away 2 is 4, so the height of this triangle is going to be 4 millimeters. And likewise, if all of this distance is 9, but this distance here is 6, then that means that this distance here must be 9 take away 6, which is 3. So working out the area of this triangle, it's going to be 4 times 3 divided by 2, which equals 6. So the area of A is going to be 6 millimeters squared. Then working out B, which I'm just going to colour in, there's lots of numbers all over the place. But again, the key values I want are the 9 and the 2. Let me just use a different colour because that's not come out great. So 9 and the 2. So the area of B is going to be 9 times 2, which is 18. So that's going to be plus 18 millimetres squared, and adding them together gives me 24 millimetres squared, and there is my final answer. So let's have a look at a more wordy question. So this says that a lawn is in the shape of a rectangle and a triangular corner cut off. The gardener wishes to put an edging strip all around the edge of the lawn. What length is the edging strip will she need? So for this, what it's basically asking me is to find the perimeter of this particular shape. Now the question is, let's have a look at, do I know what all the sides are? Well, I know what this length here is. I know what this length here is. I know what this diagonal length is, but I don't quite know what the other two sides are. So let's have a look at working that out. So here, I know that the total length of this needs to be 10, and this bit here is 6. So what plus 6 gives you 10? Well, that means that that must be 4. And likewise, looking at the top length, which is 14, so all of this length is 14, and if this bit here is 8, what plus 8 gives you 14? Well, that's going to be 6. So now I've got all my lengths that I need to work out what the perimeter of this shape is going to be. So here it's going to be equal to 14 plus 4 plus 10 plus 6 plus 10. And again, adding that all up, I get 14, 18, 28, 34, 44. So it's going to be 44 meters. The next question then says, what is the area of this lawn? Now, there's two ways in which you can work this out. Now, I could split this shape up into a trapezium and a rectangle, which is absolutely fine. Or what I can recognize is the fact that it is shaded, and you tend to find that the shaded shapes are basically the big shape. So to work out the area of shaded shapes, it's always the big shape minus the small shape. Now in this case, the big shape is the rectangle, and I mean the outside rectangle, and the small shape is the triangle. So let's have a look at working that out. So the area of the rectangle, the large rectangle, so the actual perimeter, is going to be 10 times 14, which is 140. And the triangle is going to be 6 times 8 divided by 2, which is 48 divided by 2, which is 24. So I'm going to take 24 from that, which gives me an answer of 116 meter squared, and there is my final answer. Now, typically with these questions, you might get involved in money. So a question might then follow on to say, well, fencing costs, let's say £16 per meter square per meter, and lawn might cost £3.62 per meter per square meter. In which all you then need to do is to work out the cost. So let me just write that. So to work out cost, multiply. So do the perimeter multiplied by the cost per meter. And then for the area, for the lawn, you do the area times the cost per square meter. And again, remembering that you need to round up, not round down, because you want to, when you're buying lawn or buying fencing, you'd rather have too much than too little, but you don't want to have too much wastage. So again, it's always important that you do round up to the nearest meter or to the nearest square meter. So moving on to another question here. So here we're asked to find out the area and the perimeter of this particular shape. So here you can see that I've got a semicircle and I've got a rectangle. Again, just make sure that you are working with the same units. So again, centimeters for both those two lengths is absolutely fine. Now for this, because it's a rectangle, I know that this length here is going to be 10 centimeters. That's going to be pretty obvious. So the only one I've really got to find is what this length here is going to be. So to work this out, it's the perimeter of a circle, well, half a semicircle. So the perimeter of a circle is pi times d, and because it's a semicircle, I'm going to divide that by 2. Now the diameter, although it's not attached in the dotted line, it's actually 8. So here it's going to be pi times 8 divided by 2, which is equal to 4 pi. Now, if you're happy to work with terms of pi, then you leave it as 4 pi. But if you're not, if you've got absolutely no idea what I'm talking about, all you need to do is type it into your calculator, which I'm going to do right now, and you get an answer of around 12.566376061. Now, a question you might ask is, do I need to use every single one of those digits? Well, potentially not. If you're going to round your answer up to 1 decimal place, then I'd probably say you only need to round and with this being the only decimal number you've got, then I would say you only need to round it up to, let's say, 12.6 if you want to. If it makes it easier, then do it to 12.6. However, if you had a combination of decimal numbers, then I'd probably encourage you to use more decimal places, more than what's expected. So if they want the answer to 1 dp, you write your decimals to, let's say, 2 or 3 decimal places, just in case it affects your final answer. So in terms of perimeter of this shape, now if a question asks me to leave it in terms of pi, then instead of using 12.56637.061, instead I'm going to use 4 pi. So the perimeter, and I'm going to write in terms of pi, is going to be 4 pi plus 10 plus 8 plus 10, which I can simplify all of this, which gives me 4 pi plus 28, and that's going to be in centimeters. Now if I was not using, let's say, giving my answer in terms of pi, then all I need to do is just simply add all of those numbers up. So I've got 12.56637.061 plus 10 plus 8 plus 10, and that gives me an answer of around about 40.6 centimeters, and I've rounded that up to 1 decimal place. Now when it comes to the area, again, depending on whether you're working in terms of pi or not, so the area of this rectangle, which I'm just going to call A and B, so the area of A is just a rectangle, so that's going to be 10 times 8, which is 80. I'm just going to put a box around that because I'm going to need that. Now in terms of B, so the area of B, well, to work out the area of a full circle, that's going to be pi times r squared. Now the radius of this particular circle is going to be 4, so that's going to be pi times 4 squared, which is 16 pi. And then, but I'm working with half a circle, so I need to divide that by 2. So here it's going to be, so the area of B is going to be 8 pi. Now, I can either use 8 pi if I'm going to write my answer in terms of pi. I've not used my calculator, that's just something I've worked out. Or if I'm going to type that into my calculator, I'll get an answer of, and it's going to be 25.13 centimeters to 2 decimal places. So they're the two areas that I've got. So to work out the area, and again in terms of pi, is going to be 8 pi, which is the area of B, plus the area of A, which is 80, and that's going to be in centimeter squared, and that would be my final answer. However, if they wanted me to work out the actual answer, then I would do 25.13 plus 80, which equals 105.13, and again, don't forget the unit, centimeter squared. I've rounded that up to 2 decimal places. So just be wary of being comfortable with working with pi, and if you're not too sure, I've done a video on area and perimeter of circles where this does incorporate this use of wording in terms of pi. So let's move on to our next question. So now what we're moving on to is questions that I've taken from exam papers. Now this one involves a bit of algebra. So the question says, and I'm just going to zoom in and make this question a little bit bigger. So this question says that a shape is made from rectangles. All measurements are in centimeters, which is good to know, and also that this diagram is not drawn accurately. Now the question says work out an expression in terms of x of the area. Okay, now it's not asking for the perimeter, and it's also asked me to write the answer as in its simplest form. Now for this, there's 2 ways in which I could break this rectangle up. I could break this rectangle up so it becomes 2 rectangles that way. Now the problem with this is I'm actually splitting up this 2x plus 6, which is going to be really, really difficult. If it was numbers, it wouldn't be a problem. But because this is algebra, I want to try and not touch these 2 lengths. So what would make more sense is, rather than splitting the rectangle like I've done on the screen, let's just get rid of that. Instead, what I'm going to do is I'm going to split the rectangle up into these 2 sections here. Now, if this whole length is 12 and this length here is 8, then that means that this length here must be the difference, so that therefore must equal 4. Now, to work out the area of a rectangle, basically all I've got to do is multiply these 2 numbers together. So that's going to give me 4 times x plus 4. And likewise with this bottom rectangle, I multiply 8 by 2x plus 6. So that's going to be 8 lots of 2x plus 6. Now to work out the area, that's going to be, so just writing that, I'm going to add those 2 lengths together. So that's going to be 4x plus 4 plus 8 2x plus 6. Now, because the question's asked me to write it as simply as possible, I need to expand those brackets. So expanding those brackets, I get 4x plus 16 plus 16x, and not forgetting that loop, plus 48. And then adding them up, I get 20x plus, that's going to be 58, 60, and there is my final answer. And the units are going to be in centimetre squared. And again, if I want to put that in brackets, then that is absolutely fine. So that there would be my final answer. And then finally, moving on to this other sort of exam style questions where it's worth 3 marks. I would say it's quite generous, these 3 marks, but let's have a look at it. So it says the diagram shows a rectangular mirror inside a rectangular frame. Now, depending on the photocopying and the sort of cut and pasting of this, to me that looks like a square. But again, we can't take that for granted because it does specify in the question that they are rectangles. And again, that diagram is not drawn correctly. So from this, it says that the frame is the same width all the way around. Now that is really important information when reading through this question. So what it is we need to know that the thickness of this frame, so this length here is going to be the same as that length there, which is going to be the same as that length there. Now the question's asking me first of all is to work out the overall height of that shape. Now unfortunately I know the base of this shape, so what I need to do is I know that these two lengths here are going to be the same because it tells me that the frame is the same all the way around. So here I've got that the total length is 32, but the middle section is 20, which means that 32 take away 20 equals 12. So these two blue arrows combined add up to 12. So that means that this length here must be 6, which therefore means that because the frame is the same width, that this length here must also be 6. So then working out the total of h, it's going to be 6 plus the height of the middle bit, which is 24, plus another 6, which gives me an answer of 36 centimetres. So the answer to this question then is going to be 36 centimetres. Now you might ask, well, am I okay doing my working out on the diagram? Yes, it looks incredibly messy, but if it does help, because you're labelling parts of your diagram, then that in an exam will still get you full marks. Now the next question then says work out the shaded area. Now when working out with any shaded area, it's always the big shape take away the smaller one. So the shaded area, or the frame, is equal to the big shape minus the small shape. Now the big shape in this case is the grey rectangle, and the small shape is the white rectangle. So let's go about working out each of those particular shapes. So looking at the grey rectangle, I'm just going to do here. So that's going to be the overall base, which is 32, multiplied by the height, which I've now worked out as being 36. So using my calculator to work that out, or if it was on a calculator, I just have to do some long multiplication, and I get the answer of 1152 centimetres squared. Now working out this middle section here, the white rectangle, well that's going to be again the base, which is 20, times the height, which is 24. So I've got 20 times 24, which gives me an answer of 480 centimetres squared. So to work out the shaded area, all I then need to do is 1152 minus 480, and working that out, so 1152 minus 480 gives me an answer of 672 centimetres squared. And there is our final answer. Now I will put some practice questions in the description below for you to practice all these types of questions, and obviously I'll include the answers for you to check to make sure you are getting them right.